speed कम करना।
Learn live online. To attend a free live class, download the app now.
Hey guys, hello everyone, welcome back. How are you guys? कैसे सब लोग? Hi guys, hello. Awesome. I have to come a little forward. I think my eyes are getting weaker. Okay, I can see Abhinav is here, Shubham is here, Sharat, Amit, Divit, and Shivanya. Okay, Shubham is there, Adiba is here. Very nice. Hi guys, hi everyone. Hello. कैसे हैं सब लोग? How are things guys? How are things? Good evening guys, good evening everyone. If you can hear me, if you can see me properly, just write you in the chat box. Awesome. Very nice. Amazing. Very nice. I can see all of you are here and I'm sure you guys are charged up for this session. This is the last topic of our thermal physics sprint part. Okay, cool. So guys, as you can see, I'm back with another session. This time we are going to talk about the laws of thermodynamics. This is our session in the series of sprint, and for those of you who do not know me yet, who are here for the first time, this is me, your Suri Sir, and also known as Mogambo. Why? Because when you'll be cracking this examination of JEE, the Mogambo khush hoga. Yes, okay. As you can see, I'm an alumnus of IIT Bombay, and that's my Instagram handle. If you want to follow me, you can follow me there, but I do not teach physics over there. Okay, cool guys. Okay, awesome. So guys, there is a trend that I always follow. We will be looking at the analysis of JEE 2020, which happened in the month of January. How many questions from the topic of thermodynamics came in that? We'll be first looking at the analysis of that. After that, we'll be solving obviously the questions which were there in that those 3 days of examination, all the 6 papers, and obviously there will be a question for all of you guys as your homework. Cool guys, so let's first have a look at the analysis guys. Have a look at this laws of thermodynamics. Every day there was a question, which means what? Which tells us what? A chapter not to be skipped, even for the year, this year only in the month of April. Do not skip this chapter, one of the very important chapter for all of you. What you see here guys, only on 7th of January, the first shift, you had 2 questions coming there. Otherwise, every day there was 1 question. So all in all, 5 plus 2, those were total 7 questions. Total 7 questions were there, which is a very healthy number, by the way. Okay, I've done a video on the overall analysis as well. What are the topics which are very important for you to focus? You can go through that also after this video as well. Okay, guys, cool. Now, if you think that thermodynamics is usually the chapter which you are not very good at, and there are many more chapters you want to revise the entire session, the entire preparation of physics, chemistry, maths, that is possible at Vedantu's channel as well as on our platform. For you guys, we have a Vedantu's JEE crash course. Let me take you through the features of that and the benefits that you get on enrolling with us. So obviously you get to study with us with live classes by the best of the teachers for physics, chemistry and mathematics. You get the comprehensive tests, quality assignments and the detailed analysis. Obviously, when you are appearing for the test, you need to get your doubts solved after the test is done. So your doubt solving is done by academic mentors, including me. And if you ever happen to miss out on any of the live lectures, you don't have to worry about that. You will have your replays and recordings available on the Vedantu's platform. So you can be tension free and keep up with your studies. Okay. Apart from that, yes, you get important tips and tricks to crack JEE and rank booster quizzes and previous paper analysis. So if you are interested in joining, okay, what you have to do guys, you have to follow this link which is available in the description of this video, and when you're going there, when you're trying to enroll, do not forget to use this coupon code which says SMCC. Yes, that's the code. Remember that, because the benefit that you get is this: the course which is worth rupees 20,000, you get it for just 9,500. So do not miss out on this opportunity. If you are really serious about your JEE preparation, you still have around 2 months in your hand, you can give it a good go and you can crack JEE with the help of the JEE crash course. Okay guys, yep, we will be coming up with the advanced series as well. Do not worry, right now obviously the focus is still on JEE Main 2020 in the month of April. Okay, cool. So guys, here's the very first question for all of you. Question from JEE 2020, 8th of January. Let's read the question. What does the question say? We have to choose the correct PV graph for the ideal gas for the given volume temperature graph. Okay, so there is a volume temperature graph given to us, and with respect to this, which one will be the correct PV graph is what we basically have to find out. Come on, tell me in the chat box. Tell me in the chat box, guys, what do you think is going to be the correct answer? Okay, people are saying B. Shubham says B. Come on, guys, what else? Okay, only Shubham knows the answer. How about the others? Come on, guys. Okay, I can see now people responding. Very nice, very nice, very nice. Okay. So guys, बहुत ही simple question है. It's a very, very, very simple question, easily crackable. All you have to do is think about a PV graph here. So this is pressure and this is volume, a usual pressure volume graph which we usually draw. Indicative diagram is basically what you call them. So say these are X, Y, Z. So you can see that if you look at the three processes here, first, instead of talking about X and Y, let me speak about Y to Z. You can see that if I go from Y to Z, the volume is remaining constant. That means it is a isovolumetric or isochoric process. If you look at Z to X, you can see that temperature is constant, which means what? It is isothermal process. And because X to Y is volume proportional to temperature, that means it's a isobaric process. Pressure is constant. So if I go from X to Y, the pressure should remain constant. Okay, so let me consider this as X. I'm going towards Y. Now the question should be whether I'm going from X to Y towards right or X to Y towards left. Means what? Should I be drawing an arrow on the right side or on the left side? That's basically the doubt that you should have. So for that, I will check if I'm going from X to Y, what is happening to the volume. You can see clearly that the volume is increasing. That means if I'm going from one point to another, the volume must increase. So increasing volume is from X to Y. So surely you are going in this direction. After that, what? Let's speak about, say, X to Y we are done. Let's speak about Y to Z when the volume is constant. Okay, when the volume is constant, what is happening to the temperature? You can see that the temperature decreasing, which means what? Pressure will also decrease when the volume is constant. What you have to keep in mind? PV equal to nRT. When volume is also constant and pressure is proportional to temperature, so temperature decreases, pressure also decreases, which means what? From Y, if I have to go to Z, we will not go up, we will come down because pressure has to decrease. So this point is your Z. Okay, I'm sure you are able to figure out that it's not going to be graph C and D for sure. In fact, just by looking at the direction of X to Y, you can figure out that the answer is going to be A from here itself. But we will still speak about the remaining part, which is Z to X, which is isothermal process. So let's go from Z to X. And this is how isothermal graph looks like on a PV graph, which is a rectangular hyperbola. Okay, so you can see that very easily we got the answer, and people who were there on that day obviously must have got this answer very easily. This was 8th of January, very easy question. I can see that now people are getting the answer as option A. Very well done, guys, very well done. I hope you like the question. Question is very easy, but yes, a good question to score marks. Okay. Exactly. I was not talking about the shortcuts here because you just need XY to answer this question. Because no other graph has X to Y apart from this one in the manner where we were expecting it to be. Okay, cool. Okay, guys, moving on to the next one now. This is our next question. Very similar. I've kept the questions deliberately of the same type back to back. So this one is a question, guys, which you see is from JEE 2020 once again, but 9th of January this question came. The previous one was on 8th of January. Similar type of question, but this time what is given to us is a pressure volume graph, and we have to choose the correct volume temperature graph. So all these are volume temperature graphs, and we are being given pressure volume graph. We'll follow the same thing. By that time you can start answering on the chat box. Okay, cool, guys, let's go forward. So this is our temperature and volume on y-axis, temperature on x-axis. So how we are going to go forward? Let's start with the, because it is volume, so let's start with volume being constant. That means A to B. So A to B, you can see that the volume is constant. So if volume is constant on this graph also, the volume should remain constant. But if I'm going from A to B, pressure is increasing. So at PV equals nRT tells me that if volume is constant and pressure is increasing, so temperature must also increase. So I'll go on the graph from this point to this point. That is A to B. temperature is increasing. Okay, nice, cool. Next one, so A to B is done. Next one says that, okay, one more information I missed out here. It says that process B to C is an adiabatic process. So we'll come to B to C towards the end if required. Otherwise, we'll get the answer directly. So let's speak about C to A. So C to A is basically your isobaric process. Okay, many people are saying A or B here. So let's see. So if you are going from C to A, so A pe aana hai, we have to come to A from C, and pressure has to be kept constant. That means what? When I'm coming from C to A, pressure kept constant, the volume is proportional to temperature. If pressure is kept constant, volume is proportional to temperature, which means what? If I'm going from C to A, volume is decreasing. You can see that. That means what? The temperature must also decrease. And in this case, the graph will be a straight line graph like this. Okay, so this is C. Okay, and let's say this is point C. Okay, now at this point of time, because we do not know how the adiabatic graph is going to look like directly, so let's have a look at the options, guys. So clearly you can see that this option is not correct, because B to A and A to B, this is A to B where the indicator diagram should be, it is coming from B to A, and here obviously it is not, because it says A to C, so surely A, C and D are not your correct answers. Now if we look at option B, guys, so far the graph looks very similar in both the cases. C to A is this way and A to B is in this way, means both the options look very similar. But now if you look at this for B to C, what does it say? What does it say, guys? From B to C, option B says that the temperature is constant, which means what? It says that process BC, according to this particular graph, it's not adiabatic, rather it is isothermal. But we know that B to C cannot be isothermal, it has to be adiabatic. That means what, guys? Correct answer is going to be this option. I hope you guys got the method. We didn't have to actually solve it. We didn't have to get into the mathematics behind it. All we needed was the analysis of the option A and B. Okay, cool. Yes, that graph shows that B to C is a isothermal process, which it actually not, because question says B to C is a adiabatic process. Okay, so that's our correct answer, guys. Keep it up. Next question for all of you, and this one is also from JEE 2020, and that too from 7th of January. A lot of questions came in this month, the previous month. A lot of questions came from Carnot engine. So series of questions after this are going to be on the same concept. So another concept which you should be keeping in mind. Okay, let's read the question. Question says that, question says that a Carnot engine operates between two reservoirs of temperature 900 Kelvin and 300 Kelvin. That means what? The temperature of source is 900 Kelvin and the temperature of sink is 300 Kelvin, and the engine performs 1200 joules of work per cycle. So the heat energy delivered by the engine to the lower temperature reservoir, which is sink, is basically we have to find out. So you know that if we speak about the engine, in general when we speak about the engine, this is where the source of heat is, from where Q1 amount of heat is being given, okay, and we extract some W amount of work from it, but in this process some Q2 amount of heat is also rejected to sink. Yeah, while source is maintained at temperature T1 and sink is maintained at temperature T2. Question is asking us to find out the value of Q2. What is given to you is the value of W, which is 1200 joules. Okay, now what you should know, guys, first of all, that Q1 by Q2 is equal to T1 by T2. Keep this in mind. Okay, and apart from that, if you will look at this flow chart here, Q1 is the input, W is supposed to be the output, but additional output is getting as Q2. So we can say that Q1 is equal to Q2 plus W. So W is nothing but Q1 minus Q2. Matlab kya? We were actually expecting entire Q1 to convert into W, but there is some amount of energy which gets lost to the sink, or you can say the reservoir. That is why the entire energy is not getting converted into the work, and that is what basically is the second law of thermodynamics also, that there is no such engine which can 100% convert the heat into work. Okay, now in this process, now we'll be using this Q1 by Q2 equal to T1 by T2. T1 is given to us as 900, T2 is given to us as 300. So let me either write it as let's continue in this way only, and I'll be replacing Q1 from here. Q1 is going to be, which is written already, no need to write once again, so it is there, Q2 plus W. So let's replace it here because we need Q2. So Q2 plus W by Q2. What is T1? T1 is the temperature of the source, which is higher temperature, and that is 900, and this is lower temperature 300. So this ratio is basically 3, and now cross multiply, Q2 goes here, so you have Q2 plus W equal to 3 times of Q2, and this Q2 also comes here, which means what, guys? 2 times of Q2 is equal to W, or simply Q2 is half of W. So how much is the work done over here? It is given to us as 1200 joules, which means answer is 600 joules. And if we look at, okay, there is no option, it's a integer type of question. The correct answer to this question is nothing but 600 joules. Very nice. Okay, I can see Sayyam got the answer. Very well done, Sayyam. Good job. Sanjeev as well. Shubham got the answer. Rohan got the answer. Love got the answer. Very nice, guys. Very nice. Keep it up. Keep it up. Very well done, guys. Awesome. Moving on to the next question, guys. Now, again, as I said, a lot of questions came from the concept of Carnot engine. Okay, so that's why the next question for all of you. It says that cascaded Carnot engine is an arrangement in which heat sink of one engine behaves as the source for the other engine. That means what? The heat which is rejected from one engine will be used as the primary source of energy for the second engine. And if the higher temperature for one engine is T1 and the lower temperature for the other one is T2, then assume that the work done by both the engine is same. We have to calculate the lower temperature of the first engine. Okay, means what is happening here? Say this is your, just a minute, guys. So this is your engine E1 and here is your engine E2. So from here, say the energy is coming from Q1, and from here finally Q2 amount of energy will be released to the sink of the second engine. So whatever energy was rejected from here, let's call it Q, became the primary source of energy for E2, from which some Q2 amount of heat was rejected. Okay, now this is maintained at temperature T1. This is maintained at temperature T2, while this temperature is what we are interested in finding. Also, if we see here the work done is W, and here also the work done is W, or you can say it is W1 and W2. Okay, now we know that the W1 value is nothing but this heat minus this value. That means Q1 minus Q. On the other hand, W2 value is this heat, the input, minus the heat which was rejected. Okay, guys, and it is given that W1 is equal to W2. Work done by both the engines is same, so let's equate them. Okay, so when I equate them, Q1 minus Q is equal to Q minus Q2. So this tells us that if I take this Q there and if I bring this Q2 here, what do we get, guys? We get it as 2Q equal to Q1 plus Q2. Okay, now what I'm doing, I'm taking this Q and dividing it to the right hand side. That means I have Q1 by Q plus Q2 by Q. Okay, so Q1 by Q is basically T1 by T plus Q2 by Q is equal to T2 by T, and this is equal to 2. So rearrange this. T is basically what we were supposed to find out. This is what is asked. Calculate the lower temperature of the first engine. So this is the lower temperature of the first engine, which comes out to be what, guys? Are you telling me that in the chat box? Keep filling the chat box with the response, guys. Come on, keep the Josh high, keep the enthu high. Very nice, very nice. Wow. Awesome. People got the answer as option B, and that is the correct answer, guys. T1 plus T2 by 2. Good job, guys. Good job. Awesome. Once again, I can see an awesome response on this question. Very nice. Okay, guys, moving on to the next one. And this one is relatively easy, by the way. What does this say? This says that a Carnot engine having an efficiency of 1 by 10 as heat engine is used as a refrigerator. So if the work done on the system is 10 joules as the engine, then the amount of energy absorbed from the reservoir at the lower temperature is how much? So what do you see here are the options 99, 91 and 100 joules. Question from 8th of January, JEE 2020. Okay, guys. Now, in case of refrigerator, you know that we define something called as the coefficient of performance, that is beta, and that is given as, how do we calculate that value, guys? We write it as Q2 by W. Means what? This is the work done, say, by the compressor. You all know that every refrigerator has a compressor which does the work in order to extract heat from the source or the room where the temperature is actually already low. And this is the amount of heat which is heat taken from the source. That means the room where you want to create further lesser temperature. Now, as per the question, the value of eta is given to us as 1 by 10, or you can say it as 0.1. So we can find out the value of beta. Also, the value of W is given. So we are being asked to calculate the value of the energy absorbed from the reservoir. So this is basically source, or you can call it the reservoir also. Okay. So let's calculate beta. It is 1 minus 0.1 divided by 0.1, because that's the value of eta given to us, that is 1 by 10. Okay, guys. So what do you get here? This comes out to be 0.9 divided by 0.1. That means beta value comes out to be 9. And what is that equal to? It is equal to Q2 by W. That means what? Q2, which we are interested in finding, comes out to be 9 times of W. And how much is the work done? Work done is given to us as 10 joules. So 9 into 10. I am hoping answers on the chat box already. This is our answer. Very simple. Option B. Very nice, Abhinav. Yes, B pakka is the answer. Kuch bhi kacha nahi, everything is pakka. Sanjeev, Pawan, Nitesh, Nick, Sayam, Pushpa, Astha, David. Everyone got the answer. Very nice, guys. Very nice. Awesome. Awesome, guys. You can see we got the answer very simply. Okay. This is another question from JEE 2020. Okay. Next one. Okay, guys. From 9th of January. Let's read the question. Now, this one is not from the Carnot engine. It says that an ideal gas at initial temperature of 300 Kelvin is compressed adiabatically. The value of gamma is given 1.4. And it is compressed to 1 by 16th of its original volume. Okay, and the gas is then expanded isobarically to double its volume. Then we have to find out the final temperature of the gas round to the nearest integer. So another integer type of question. No options are given over here. Okay, so guys, if I try to plot it on a PV graph, so say this is your indicative diagram for this particular question. Okay, so say you start from here, and first you have to compress adiabatically. So if you are reducing the volume, so obviously the pressure will increase, and we know that the graph for adiabats are something like this. So this is how you are taking it from volume, say V1. This was the volume, and here the volume becomes V1 by 16. This is what the question says. Say you have taken it from point A to B. Okay, that's what is happening to the gas when it is compressed adiabatically. Its volume becomes 1 by 16th of its original volume. Okay, so it was V1, it becomes V1 by 16, and let's call this volume to be V2. Okay, after that the question says that the gas is then expanded. Now the volume will be increased isobarically, that means pressure will be kept constant to double its volume. Means what? Now from here the pressure will be kept constant, so obviously it will be moving like this. So whatever is the value of V2, it will become double from there. So this is basically your V3, which is 2 times of V2. I hope you guys are getting it. Okay, so this is your point C, and this is the direction. Got it so far? A to B we went adiabatically, compressed from V1 to V2, which is V1 by 16 now, and from V2 we expanded isobarically to make the volume double from there. Now what is given to us is that the initial temperature of the gas is given as 300 Kelvin. Okay, that means what? If I get the value of the temperature here, what is going to be the temperature of the gas when the gas is being taken to B, then it will be easier for us to solve, because after that it's just simple isobaric expansion. So let's first speak about the adiabatic case. We know that the relation between temperature and volume is Tv to the power gamma minus 1 being a constant. So T1 V1 to the power gamma minus 1 equal to T2 V2 to the power gamma minus 1. Okay guys, now what? The initial temperature is given to us as 300 Kelvin. Initial volume, let's call it as V1. Its power is gamma minus 1. How much is gamma, guys? Gamma is 1.4, and minus 1 from that, what am I going to get? I'm going to get it as 0.4. T2 obviously is unknown, and V2 is V1 by 16, and this is also 0.4. So you know that V1 and V1 will get cancelled, and 16 to the power 0.4 will come to this side. So I have T2 as 300 into 16, which is 2 to the power 4, and outside the power is 0.4, which you can also write it as 4 by 10 or 2 by 5, which means what, guys? You can write it as 300 into 2 to the power 8 by 5. Okay, so that's what we are getting as the temperature at B. This is when the gas has been taken to point B. Okay, now what is happening from B to C? Now we have the temperature there as well, and now we are expanding the gas isobarically. When the pressure is kept constant, what happens to the relation between volume and temperature? You are aware about that V2 T2 will be equal to V3 T3. Okay, no, this is not the correct relation. PV equal to nRT. Pressure is kept constant, so V1 by T1. So that way V2 by T2 will be equal to V3 by T3. How many of you got that? Nahi, Fezulo Gaming, I'm not forgetting you, don't worry. Okay, so this is what is going to be the relation as per this. Volume is proportional to temperature. So V by T is basically a constant. So what is V2 here? We have already talked about V2. V2 is basically V1 by 16. Okay, and V3 is double of that. So instead of writing V2, we'll write V3 as 2 times of V2. And we have already found the value of T2 as well, by the way. 300 into 10 to the 300 into 2 to the power 8 by 5. So T3, guys, which basically is what we are interested in finding. Yeah, so that will be what? V2, if T3 goes to this side, you will have V3 T2 by V2. Okay, so V3 is 2 times of V2 divided by V2, and this is T2, and T2 we can write the value, which is 300 into 2 to the power 8 by 5. So V2 gets cancelled, guys. So what do I have? I have 2 into 2 power 8 by 5 into 300. Okay, so when we simplify this, by the way, is when we get an integer answer close to 18 1819 Kelvin. That's basically the answer to this question, guys. 1819. Yes, exactly 1818.85 is the answer. The value actually comes out to be 1818.85, but then obviously because the question is asking you to round it off to the next integer, so the next integer value is 1819. Very well done, guys. Very well done. Awesome, awesome. Okay, very nice, S. Smith. You got the answer right, exact value. Perfect. Good, guys. Nice. Now, a question from JEE 2019. Okay. There's one more question which is from 2020, but that will be a question for you guys to do at homework. We'll be giving you that towards the end of the session. Okay. Let's read this question, guys. Question says that a gas can be taken from A to B along two different paths. So you can see that a graph has been given with gas being taken from A to B, one via path ACB, second one path ADB. Now what the question says is that in path ACB, 60 joules of heat flows into the system and 30 joules of work is being done by the system, which means what? Q has been given and work has been done by the gas. Means what? If I write Q equal to delta U plus W for path ACB. So this is given, we can find out delta U. And you know that delta U is a function of change in temperature only. Means what? If you are taking the gas from A to B via path ACB or ADB or any other path, the change in internal energy will remain same because the temperature difference between A and B is going to remain the same. Okay, that means what? The value of delta U can be easily found as Q minus W. How much heat has been given? 60. How much work has been done? 30 joules. That means delta U comes out to be 30 joule. Have you guys already got the answer for the second part? Because in the path ADB, the question says that the work done this time is only 10 joules. We have to find out the value of heat flowing in that. Okay, flooded with the response. Very nice, guys. Let's see if it is the correct answer or not. So for path ADB now, so Q dash will be equal to delta U plus W dash. Okay, delta U remains the same. So Q dash will be equal to 30 plus 10 because work is done again by the gas. Whenever work is done by the gas, work done is positive. Remember that. Whenever heat is given to the system, to the gas, heat is positive. Whenever work is done by the gas, work done is positive. So if work is done on the gas, then basically the work done is negative. And if heat is taken from the gas, then your heat extracted will be negative. So what do we get as the answer, guys? Q dash comes out to be nothing but very simply 40 joules. And yes, as many of you got it, correct answer is 40 joules. Awesome, awesome, wow. Very nice. I can see Pawan, Pushpa, Abhijit, S. Smith, Nitesh, Abhinav, and what? Astha, Nitesh. Everybody got the answer. Very nice, guys. Very nice. A for awesome. Yes, that is what it is. Cool. Okay, guys. Let's have a look at another question that is also from JEE 2019. Let's have a read to this question. Question says that a rigid diatomic ideal gas, okay? Can anyone tell me the value of gamma for a diatomic gas? Cp by Cv ka ratio. Can anyone tell me in the chat box for a diatomic gas? How do you write gamma for a diatomic gas? Fractional value, preferably. Okay, I can see Love responded, Sanyam, Nitesh also got the value. Perfect, perfect. Astha also got it right. That is 7 by 5. Though it is not needed in this one, can you tell me for monoatomic as well, guys? Let's have a quick revision on that. Can you tell me for monoatomic gas? For monoatomic gas now I'm asking. Cp by Cv is always more than 1, by the way. It's 5 by 3. Okay, remember that, guys. We'll be needing the value for gamma for diatomic gases. Okay, guys, let's read the question. A rigid diatomic gas undergoes an adiabatic process at room temperature, and the relation between the temperature and the volume has been given to us. What is that relation? T v to the power x is given as constant, and we have to find out the value of that x. As simple as that. So we know that T v to the power gamma minus 1 is the relation which is valid in the case of adiabatic process. Okay, it has been given already. Okay, the process is adiabatic. So let's compare it with T v to the power x. Now all you have to do is compare x with gamma minus 1. So your x value is gamma minus 1. Have you got the answer, guys? Okay, some people are getting it as A, some are getting it as B. Okay, let's see. So gamma is nothing but 7 by 5 minus 1. What do you get, guys? 7 minus 5, 2 by 5. Such a simple question. Correct answer is A. Again, A for awesome. Yes, yes, yes. Perfect, perfect, guys, perfect. See, such easy questions have come in JEE and they keep on coming. So again, another question from JEE 2019. Okay. So guys, how are you liking the session? How are you liking the questions? Tell me that quickly. How did you like the questions so far? Easy, yes. I always say that these are easy questions because these questions have come in JEE, and I always tell that JEE has easy questions every time. So all you have to tell yourself that I will crack JEE because JEE is filled with all these easy questions. Okay, now if that is not enough for you to get motivated, I have a source of motivation for all of you. Those are Vedantu's own results from 2019 as well as 2020. So guys, 2019 JEE Advanced, we got All India rank 697, All India rank 41 and All India rank 38 as well as All India rank 1 in the reserve category. So guys, these are the awesome people who made it to IITs by cracking IIT JEE entrance examination by those awesome ranks. And not just that, for JEE 2020 in the month of January, people scoring 99 percentile or more than that, 117 students of Vedantu got that, and 592 students they got into 90 to 97 percentile bracket, and 490 students who were very close to the 90 percentile. Okay, so what do you think? Can your photo be here? Yes, that is possible. If you're a student who's in 11th standard right now, in 2021, you can be here, and then you still have one more opportunity for people who are now going to appear for JEE examination in the month of April. Okay, guys, apart from that, let me share the board results also with you all. Well, we got 98.2 and 97.8% in 12th standard CBSE examination by the very own people who cracked the JEE Advanced examination with awesome ranks as well. Apart from that, in 10th standard CBSE, 98.2, 98% marks. In ICSE as well, 98.4 and 97.4. Awesome people. Yeah, and we had 7 fellowships from KVPY and pre-RMO, 25% selections. Amazing or not, guys? I hope these results serve you as a source of inspiration. I'm sure you guys get a lot of inspiration from our channel, from all the people you meet here. Yeah, now the time comes for the question which is there for you as homework. Okay, have a look at this, guys. I'll get aside for around 5 seconds so that you can take a screenshot. Meanwhile, I'll read as well. 1 liter of gas at standard temperature and pressure is expanded adiabatically to 3 liters. Okay, so volume is becoming from 1 liter to 3 liter. You have to find the work done by the gas. Gamma is given, and also what is mentioned that 3 to the power 1.4 is 4.65. I hope that value will come useful and handy for you all. Options are given. Question from JEE 2020, 7th of January. So do write your final answer that you get in the comment box once you are done solving it. I will obviously respond with the correct answer in the chat box myself, as I always do. Okay, guys, one more important thing that I want to tell you all here only today. As now your board examination are approaching, many of the students I talked to you guys in the previous sessions, their board examinations are already going on. So now we'll be putting a pause on the sprint session as of now for JEE, do not worry, we'll still be meeting, we'll be coming up with content as well as the discussions, derivations, problem solving with respect to your board examinations, and we will be, listen to this carefully, we will be resuming the JEE sprint sessions immediately after your board examinations gets over. Okay guys, remember that. Remember, sprint is coming to a hold. We are not stopping it. We'll be resuming it immediately after your board examinations are getting over. We'll get into the sprint mode once again, and we will be in touch. We'll be solving questions. We will be meeting again, but with respect to your board examinations. Okay guys, I hope you guys are doing well for your board examination preparation and keeping the JEE preparation also going on along with that. Okay, so on that note, I'll take your leave guys. And before I leave, I always say that is LSS. If you are enjoying the sessions with us, do hit that like button. Do share this with your friends. Let them also take the advantage. And if you have not, then subscribe to the channel guys. Okay, till then, keep smiling, keep studying physics, and keep rocking. I'll see you again. Bye-bye. Take care guys. Bye-bye.